better late than never. It's 3:28. We're going over number 3 on the mixed FIP. So we have work kinetic energy theorem. Kinetic energy is equal to the net force times d cosine theta. In this case, because the distance and the net force are in the same direction, cosine is 0. Should I be worried that my phone is getting hot enough in my pocket that I suddenly notice it?
Maybe.
I do not have a 7. It is a good old little 4. Why is it suddenly heating up? Suddenly it's heating up and the battery is going. Is this something that, this is my first smartphone ever. I've had it, this is the first smartphone I ever got. I had flip phones before this.
How long have you been out?
3 years.
It might just be dying.
And that's what happens? Because suddenly I feel like my leg is on fire.
Like draining a lot faster once they start.
Yeah, I mean, I knew that at the end of battery life that would happen, but why is it like a little hot rock in my pocket? No, it's always been in my pocket.
There was a thought with the 7 that the battery would explode.
Right. Yeah, I know. And this is not a 7. It's a 4. Hence my comment. It is not a 7. It's really hot though. Okay, well, I'll just. Where else am I gonna put it? I'm gonna forget it. I'm gonna drive home. I'm gonna get halfway home. I'm gonna not have it. I live an hour away. That doesn't. Have you met me? That's not gonna work.
Why don't you just set an alarm on your phone? Yeah, set an alarm on your phone that,
Yeah, so when I'm halfway home, it goes off in my desk. Brilliant. You, ma'am. You. Oh.
Why don't you set an alarm for after you go home?
Exactly. Okay, let's go back to gravity. Jeez Louise.
Do we have a fire hazard right now?
It's cola scented.
But no one else noticed it.
It's because I do it every day. They're completely desensitized. I love this marker.
Yeah, we've had this conversation.
We have.
I watched you do both on the
Yeah. Color under your nose.
I think
That's a great idea, Annie.
I might have noticed what I've done, so I'm fixing something.
Okay.
So I'll let you know.
And let me know. Okay, so we know this is going to be mass gravity, sine of 16. What a tremendous bunch of goofballs to start my day with.
We're second grade, actually.
Yeah, but I have planning first. So I do start my day with you goofballs. Okay, so we know that mu k equals fk over fn. We know, therefore, let me shrink. We know lots of things. Don't get into all that philosophical, solipsistic crap. Makes for great teenage angst. You'll outgrow it. You'll be fine. You will. Okay. So we know that mu k fn equals fk. And we know that if we do sum of forces on the y, it's 0 because this thing is not spontaneously levitating up into the air. So Fn equals mass gravity cosine 16. So far, so good? Okay. So I'm going to get rid of all that because we proved that we have the pieces to plug in to get the net force. And yes, this is one of those weird problems where it's actually harder if I ask you for less. If I did parts A through D and I asked you for the work done by the polar, the work done by gravity, the work done by friction, and then that's actually easier because then you have all the works calculated and you can just go ding, 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 ding. Asking you for less actually makes it harder because you have to do more back work that you haven't already done. It's reverse evil. Okay, so I actually went ahead and just plugged everything in like this. Delta K substitution is my friend. So I have F applied minus, and I just proved what this was, mass gravity sine 16 minus mu k mass gravity cosine 16 times distance. Okay, well that would get you a different answer. So I got that. Did you forget mu k by any chance? You wish. I do wish, because that would be a simple explanation.
For the FK, it would be negative mg cosine theta.
Yeah, it'd be minus mu.
Okay. Yeah, no,
Yeah.
I'm solving that.
Okay. All right. Oh, good Lord. All right. You people are crazy.
Get wrecked.
All right, so I got this. And I got this whole mess times 6.5 meters. It is because I factored out the 42.9 the other way.
Now you're subtracting.
So, well, you're subtracting them both because they both should have same magnitude, which I did before, but I'm convinced there was an issue with my algebra if there's an issue. Okay, so we are now getting, and this is different than the answer I got on the FIP, 22804.67658 joules would be the change in kinetic energy. That would sig fig to 23,000 joules. Okay, so I got to figure out what my issue was with those. Yeah.
Or you're subtracting.
Yeah. Doing somewhere factoring screwed it up. Okay.
Doing this, I couldn't think of a elaborate way to plug in all the algebra stuff.
Yeah.
Like that, because I get confused sometimes. So I was like, well.
And this is a really good example of there are 6 ways to get there. 4 of them will get you an answer. 3 of them will get you the right answer. So what you did will get you the right answer. You can find final velocity. You can find final KE. You can find initial KE. You can subtract the difference.
At first I was getting the wrong answer because I forgot to include gravity
Okay.
on the X.
That will do it.
And then
Some people forgot to include friction.
Yeah.
So, you can find the net force. You can find the net work. You can do all the works for each individual piece. You can do any of those things. I do think this is the simplest, sort of most straightforward. Yes, ma'am. I stand Annie corrected. It's the issue with my factoring job is that I'm factoring out the mg, which would change a sign here because I need to factor out the negative. I factor it out as a negative mg.
Right.
So I need to get rid of this. Well, I can't really do that, but anyway, that would make that a positive, and that gets us the right answer. So I had the issue, and that was some detective work to find it. So good job, Annie. Gordon paused this morning. If somebody is pulling it up the slope, so it's moving up the slope, but we're looking at the work done by gravity, the force of gravity is down, you would put the arrow that way. The distance it's going is this way, it's cosine 180. So,
You said this was 5 feet.
yes.
And what your F net would represent.
Well, or what your which F you're dealing with.
Because if it was dealing with just friction, then it would be going down.
Then it would be going the same direction. No, it would be going opposite directions. Because in this case, both the forces are pointing down slope, but it's traveling up slope because it had an initial velocity. So you're looking at whichever force you're dealing with.
Okay.
If you look at these, they're both going down slope, but the sled's moving up the slope.
So if you had an F applied,
If you had an F applied up, then
then it
That's
would be
just
up.
cruising down though, right?
yeah, it's just cruising down. Then if you were dealing with the work done by the puller or the applier, then it would be cosine 0 because that force is up and this thing is still traveling up.
If you're dealing with
If you're dealing with,
all of it,
you have to look at the net force and which way it's,
what way it would,
yes,
if it would be negative or positive.
Yes.
You have to figure that out. And then if it's
Yes.
negative or positive, it's cosine of 0 or.
yes.
Okay.
Wait,
Okay.
what's the friction in the same direction as the gravity?
Friction is in the same direction as gravity because friction opposes motion universally and this thing is sliding up the slope.
Oh, it is?
Yeah, it got kicked up the hill and it's going up, slowing down, coming back. We want to know how far up it goes. So it is still going up the hill.
That's pretty neat. We can find out.
We can figure out all kinds of stuff. I wish we could do chapter 6, impulse, force, momentum. That's a whole bunch of fun, but we can't do it. Okay, other questions? Tomorrow is your chapter 5 test. If you have not taken the electronics pre-survey, I think only 12 people took it, you need to make sure you do that.
And you did
It's on Classroom.
Are you not allowed
you have
to
paper clip.
check
This
this?
No, we just don't have time. I gotta get you into circuits. I did it 1 year, and that was bad planning on my part because we didn't do any electronics. So, okay.